Welcome to Introduction to Logarithms. Our new vocab word for this unit is, of course, that word logarithm, and we're going to start out with the definition of what a logarithm is. Right here in green, I have written log base b of a. Log is the abbreviation that we use for the word logarithm, and the way we would say that expression is log base b of a. Notice b is in the subscript, so it's a little bit lower down than the other things that are written log and a. What the heck does log base b of a mean? Well, if I set that equal to x, I now have a sentence. Log base b of a equals x. The definition of a logarithm tells us that that sentence is equivalent to this sentence. B to the power of x equals a. Those two things are saying the same thing. B to the x equals a is probably more familiar to you. It's an exponential sentence. Log base b of a equals x is really saying the same thing. Let's take a look at a couple of examples to really see how these logarithms work. You hopefully know that 2 to the third power is equal to 8. Let's put that in log form. According to our definition, the 2 in this case is in the same place as the b. So the 2 is going to become our base. I can write log base 2 of, now I notice that the a is the next thing I would write down, and the a is in the same place as the 8. So I can write log base 2 of 8 equals 3. We notice that the x is in the same place as the 3. So I just kind of played the matching game, and I started with a sentence that we knew was true in exponential form, and I rewrote that same sentence in log form. Log base 2 of 8 equals 3. Another way of thinking about it is that 2 to the power of 3 equals 8. The exponent that we put on 2 to get 8 equals 3. What if I started out with this sentence? Log base 4 of w equals 17. Do you think you could write that in exponential form? Well, let's see. That would mean that 4 to the power of 17 equals w. Just by using my definition up at the top in green, I kind of played the matching game and figured out where the 4 would go, where the 17 would go, and where the w would go in our exponential sentence. What if I gave you all variables? Z to the p equals q. Could you rewrite that in logarithmic form? Maybe pause the video for a second and see if you can do it. In logarithmic form, it would look like log base z of q equals p. The placement of each of those items is very important because that's very different from something like log base q of p equals z. It's a different sentence. So take a moment to absorb these three things that we've written. Note that everything on the left-hand side is logarithmic form. Everything on the right-hand side is exponential form. Being able to switch from one form to another is going to become very important. So it's important that you feel comfortable with the green definition and being able to go from one form to another. Let's do some evaluating. Now that we know how to switch forms, what if I just asked you straight away for log base 3 of 9? I'd like to know what that is actually equal to. One way we could think about this is call it x. I don't know what it is yet, but let's just call it x and switch forms. Maybe then, once I have it written in exponential form, it'll be easier to figure out. I know that that's 3 to the x equals 9. You know the answer to this. 3 to the what power is 9? Why, 3 to the 2 is 9, so x must be 2. Therefore, log base 3 of 9 is equal to 2. The question we asked ourselves was 3 to what power is 9? Logarithms are exponents. What is the exponent we put on our base 3 to get 9? 3 to what power is 9? These are the questions that you ask yourself when you're evaluating a logarithmic expression. Let's try another one. How about, can you evaluate log base 2 of 32? Maybe pause the video for a second, see if you can get the answer. I'd want to ask myself, 2 to the what is 32? That's what I'm thinking about here. Well, I know my powers of 2, and I know that 2 to the 5th is 32. Therefore, log base 2 of 32 equals 5. The answer to our question, 2 to the what is 32, is the number 5. So log base 2 of 32 is 5. These seem pretty easy. Can we get a little bit more complicated? How about this? Log base 2 of 1/2. What does that equal? 2 to the power of what is 1/2? That's the question we ask ourselves. I know I can rewrite 1/2 as 2 to the negative 1. We have to be comfortable with our negative exponents. Oh, 2 to the negative 1 is 1/2. So our answer is negative 1. Don't forget about those. Don't forget about negative exponents. You try this one. Log base 3 of 1/27. Try pausing the video for a second and seeing if you can get this on your own. I know that 1/27 can be written as 1 over 3 cubed, which is 3 to the negative 3. So when I ask myself 3 to what power is 1/27, that's negative 3. Did you get it right? Hopefully. Let's talk about a couple things you might see involving logs. How about log base 49 of 7? Ooh, this looks a little scary because our base is kind of big. But I bet you can think of a way that 49 is related to 7. Hopefully you remember that the square root of 49 is equal to 7. Another way of rewriting the square root of 49 using exponents would be 49 to the 1/2 power. That's back from our radical functions unit. Okay, well I know that that's equal to 7, so I've kind of answered my question. 49 to what power is equal to 7? 49 to the 1/2 is equal to 7. Therefore, log base 49 of 7 equals 1/2. Don't forget about fractional exponents. So far we've had to remember about negative exponents and fractional exponents. Fun stuff. Let's just talk about a couple of other facts that we might see with logarithms. What if I asked you for log base 5 of negative 25? This question says 5 to the what is negative 25? If you're having trouble coming up with the answer, then there's a good reason for that. There is no real number that works for this. So this is undefined. I can't have log of a negative. What if I asked you for log base 5 of 0? 5 to the what power is 0? Again, if you're having trouble, there's good reason. This is also undefined. So if I'm trying to find the log of a number, I have to be sure that the number that I'm finding the log of is positive. It can't be 0 and it can't be negative. How about this one? Log base 5 of 1. Well, the question you would ask yourself is 5 to the what is 1? Did you get it? It's 0. 5 to the 0 is 1. In fact, anything to the 0 is 1. You try this one. Log base 197 of 1. It's 0 because 197 to the 0 is equal to 1. So I can ask you log base anything of 1. It's always going to be 0. There's two more definitions associated with logarithms, and they are special logarithms that you'll see all the time. The first one is known as the common logarithm. And that is log base 10. In fact, it's so common that we don't even write in the 10. So if you just see log of x, you need to know that that's the same as log base 10 of x. Just like with square roots, the square root was so common we never wrote in the 2 as the index. Same kind of idea here. Base 10 is so common we don't write in the 10. So you need to know that log x is the same as log base 10 of x. So if I asked you, evaluate log 10, you would ask yourself, oh, okay, I know that that's log base 10 of 10 really, because the base wasn't written in. 10 to the what is 10, and that's 1. There's only one more special logarithm you'll see, and that is called the natural logarithm. And that is log base e. Remember, e was about 2.718281828459045 ... That number e, the natural number, that comes up so much in math that we have a special log, base e, that we assign a different name to. We call that a natural logarithm. Now, the way we abbreviate natural logarithm is ln. In fact, sometimes I make a script L to emphasize that it really is an L. Otherwise, it kind of looks like a capital I. So if you had natural log of x, we would abbreviate that ln x, and what that really means is log base e of x. That number shows up so much that we've assigned a special name for log base e. Now you might be asking yourself, it's natural log. Why is it ln and not nl? And that has to do with the fact that it's coming from the French, logarithme naturel, where the adjective actually comes after the noun. That's why we use ln instead of nl. So if I asked you for a natural log of 1, how would we figure that out? Well, I know that that's actually log base e of 1. E to the what is 1? Well, anything to the 0 is 1, so our answer is 0. If you are super comfortable with the definition of logs and the question that you are asking yourself when you're evaluating logs, then this probably won't be so bad. But it is going to take some time to get comfortable. So there is going to be a lot of practice for you to try. Good luck!